Chapter 5 begins on page 263. It has a title of Exponents, Polynomials, and Polynomial Functions. And I'm going to give you some good news. No. Hang on, I got to pause. The good news about Chapter 5 is that it should all be review. If you took the beginning algebra class here at Shawnee College, Chapter 5 in 043 is the same thing as Chapter 5 in 041. By the way, Chapter 6 in 043 is the same thing as Chapter 6 in 041. That's factoring. This chapter is about polynomials. That's where we're headed. By the end of the chapter, we want to be able to add, subtract, multiply, and divide polynomials. But to do that, we have to know how to work with exponents. So the first section, I should say, is all about how to deal with exponents. Okay, so let's dig in on our journey into some rules for exponents. It is 5.1, yes sir. So the first rule we're going to look at is called the product rule. Hey class, what does the word product mean to do in mathematics? It means to multiply. That's right. So we're dealing with when we're multiplying and our bases are the same. It'd be a situation like this. If I had a to the m times a to the n. See how the bases are the same? They're both a. So does anybody remember from a previous class when the bases are the same what we do with the exponents? If you don't know, let's go over here and do some exploring. Okay, and we'll figure it out. If I had x squared times x cubed, wouldn't that mean x times x times, what's x cubed? X times x times x. Well, now what do I have if I have x times x times x times x times x? I have x to the fifth. So what are we going to do with the exponents when the bases are the same? We're going to add them. To go from here to there and skip this, we want to add the exponents. Okay, so the rule goes like this. A to the m times a to the n is equal to a to the m plus n. So when you're multiplying, add the exponents.
When you divide, you subtract them.
Yeah, but we'll get to that. So let's look at a few examples over here. I don't know why I wrote example 2. I just meant to write examples. Yeah, we'll do those in red just to shake it up a little bit. So if I had 3 to the 4th times 3 to the 7th, the base stays the same, but we add the exponents. So that would be 3 to the 11th. Now in my 041 classes, I live with my students leaving answers like 3 to the 11th. But in this class, I want to know what 3 to the 11th is. So if I take 3 to the 11th power, I get 177,147. Yes, that's what I'm saying. Yes, you do have to. Okay, let's look at a few more. Mr. Black, what if there's 3 factors? Like what if I had y to the 3rd, y to the 8th, and y squared? Well, it doesn't really change anything. We're still multiplying. The bases are still the same, so we're still going to multiply add the exponents, I should say. Y to the how many, class? Y to the 13. Good.
What's the number? I don't think I remember like to the power button on my calculator.
Give me a second. I'll come show you. Aaliyah, you asked a question.
I was making sure the number on the last one was a 2.
Yes, ma'am.
Okay.
Okay, now, what if our variables have coefficients besides 1? Like 5y squared and negative 3y to the 4th. So class, here's a saying that I would commit to memory. Coefficients, you treat like normal. You do what you've always done with them. 5 times negative 3 has always been negative 15. And then we'll add the exponents on the y. How about negative 15y to the 6th? How about that? Aaliyah.
So if we have one with the exponent on the outside, would you multiply the exponent?
We'll get to that.
Okay.
Okay, so we know what to do when we're multiplying and the bases are the same. We're going to add the exponents. Okay, the product rule, ladies and gentlemen. Very good. Now let's move it on down the road one step. And this time we are going to discuss what happens if we have a 0 exponent. So I think this is one of the rare times I'm going to forego the explanation as to why and just give you the rule. If you want to know why, we can talk about it in a little while. But for right now, here's what I'm going to tell you. Any real number raised to the 0 power is equal to 1. The exception of that is 0. 0 to the 0 is not 1. But every other real number to the 0 is equal to 1. Do what? Plain variables to the 0 power is equal to 1. If there's no variable written, I said that wrong. If there's no exponent written, then the exponent's assumed to be 1. So like a would be a to the 1st. So that wouldn't equal 1. Okay, so let's play a little game here. Let's go to Caitlin and Aiden. What's 6 to the 0? What's that equal to? There seems to be some disagreement. Let's have a tiebreaker of Hannah. Hannah, what's 6 to the 0?
1.
It is 1, that's right. Every real number to the 0 power other than 0 is 1. Somebody in the whole wide world, what's 125 to the 0 power?
1.
What is your grandma's left elbow raised to the 0 power? It's 1. Yeah. Okay. Now, what about these two things? Let's talk about them. Negative 6 to the 0 as a quantity. And let's compare that to negative 6 to the 0, not in parentheses. Well, I'll do the first one. We just said any real number except 0 to the 0 is 1. So negative 6 to the 0, that's 1 right there. But that is not what the second one says. It does not say raise negative 6 to the 0. It says raise 6 to the 0 and then make it negative.
So negative 1?
It is negative 1. That's right. And what you're doing there is you're following the order of operations. You're applying the exponent before you apply the minus, just like the order of operations say. So this is actually equal to -1. Good job. Okay, are we good with the zero exponent, ladies and gentlemen? Okay, moving on down the road. So the next thing we're going to discuss is the notion of a negative exponent. So in a moment we're going to look at an example of how we would handle 2 to the -3 power. Okay, you know what? I want to table this and come back to it. I'm going to go in reverse order this time. So just leave that there. Go down further on your paper. We'll come back to that. Let's go ahead and discuss the quotient rule. There you go. That's thinking as you write. Some very smart person here on main campus said it's got something to do with division. And that smart person is correct. Okay, so this deals with when I have something raised to a power divided by something raised to a power. Now class, let's not make rocket science out of this. Things make sense if we just think. When we multiplied, what do we do with the exponents? So when we divide, what are we going to do with the exponents? We're going to subtract. So a to the m over a to the n would be a to the m minus n. So if you wanted to apply that rule to something like this, 3 to the 7th over 3 to the 2nd, that would equal 3 to the 7 minus 2, or 3 to the 5th. And according to my calculator right here, 3 to the 5th power is equal to 243. Now, to be honest with you, that's not usually how I do that problem. I don't usually think of it in terms of the quotient rule. So let me show you the equivalent way to think about this that I think is simpler to think about. So here's what I do. Okay, I don't write all this out, but here's the way the line of thinking goes. Wouldn't 3 to the 7th mean 7 factors of 3? Which again, I don't usually write all the way out, but I'm trying to make a point here. Is that 7 of them? 1, 2, 3, 4, 5, 6, 7. Yes. And wouldn't 3 squared mean 3 times 3? Now, what I could do is then cancel those 2 3's on bottom with 2 of the 3's on top, couldn't I?
Yeah.
Okay. And that'd leave me with 5 3's on top, which would give me the 3 to the 5th, or the 243. So that's usually the way I think. I just think in terms of canceling. 2 of these 3's will cancel 2 of these 3's on top, and it'll leave me with 5 3's on top, and I get 3 to the 5th. Okay, so moving forward into class, that's the way we're going to go about things. We're going to think in terms of canceling. So if I've got k to the 7th over k to the 12th, do you see that I'm going to be able to cancel 7 of the k's? 7 of these will cancel 7 of those. And it'll leave me with 5 k's on the bottom. Now class, don't forget, when everything cancels out on top, it gives you a 1. So how about 1 over k to the 5th on a problem like that? And that's usually how I take care of the quotient rule. I just think in terms of canceling. Okay, now we're going to give this lesson a timeout, and I'm going to do some thinking on my own here as to what I want to go next. The next thing I'm trying to do is we're going to work backwards now and figure out what this negative exponent was going to say. That's where we're headed. How to handle 2 to the negative 3. But usually when I show the rule, students kind of look at it cross-eyed and they think, well, how in the world does that happen? So I'm going to try to explain to you how it happens. So what I talk through here on the paper, you don't need to put in your notes. You just need to think with me for a moment. Okay? So let's consider these two little problems here. Do you agree that if I had y to the 8th over y to the 6th, that 6 of these y's would cancel 6 of those and give me y squared in the numerator, and y squared over 1 is just y squared? Okay? Head shakes. Okay, it's just like what we just talked about. Now, what about y to the 6th over y to the 8th? How would that work? Well, 6 of the y's would cancel. These 6 would cancel 6 of those and give me y squared on bottom. It'd leave me a 1 in the numerator. So it'd give me 1 over y squared. But watch what else it would give you. If I did apply the quotient rule by subtracting, if I subtracted 6 minus 8, do you see that it would also give me y to the negative 2? So what I'm claiming to you is that 1 over y squared and y to the negative 2, they're both equal to the same thing, so they have to be equal to each other. They have to be. So, to make a negative exponent positive, do you see that we can take the factor that contains the negative exponent and put it in the denominator, and the exponent will become positive? Okay, that's the idea behind how we handle negative exponents. I'm going to repeat that sentence that I just said. So if I have something raised to a negative power, I just said, here's the sentence again, to make that exponent positive, I can move that factor to the denominator, and the exponent will become positive. So if a to the negative n goes to the denominator, it'll be a to the positive n, and I'll have 1 over a to the positive n. Now, with my beginning algebra classes, I call that changing the level. Change the level on the factor, and you change the sign on the exponent. I'll spare you the details here, but it also works in reverse. If you have a negative exponent in the denominator, like 1 over a to the negative n, if you change the level on the factor, move it to the numerator, the exponent will become positive. So I'd have a to the n over 1, which is simply a to the n. So to make an exponent positive, you change the level. That's it. That's what we're saying. So if you had 2 to the negative 3, change the level, we'd have 1 over 2 to the positive 3. Hey class, what's 1 over 2 to the positive 3 equal to?
6.
Close. 2 times 2 is 4, times 2 is 8. It would actually equal 1/8. 2 to the negative 3 is actually equal to 1/8.
And you're gonna want us to write that.
Yep. Yep. We're going to want 1/8 instead of 1 over 2 to the third. So let's look at a few more scenarios we could run into here. What if I had double negative exponents? This stupid pen's not writing the way I want it to. Try it again. Let's say I had 2 to the negative 3 over 3 to the negative 2. Well, I don't want to leave any negative exponents, so this time both of them are going to have to move.
So they're both just gonna replace each other's spots?
Yep. 2 to the negative 3 is going to go downstairs and be 2 to the positive 3. 3 to the negative 2 is going to come upstairs and be 3 to the positive 2. And now 3 squared is 9. And 2 to the third is 8. 2 to the negative 3 over 3 to the negative 2 is actually equal to 9/8. Who would have thought it?
And you want that as an answer? Do you
Yep,
want it simplified?
that is simplified. It's not a mixed number, but it is simplified. Okay. Now, let's go a couple steps further then. What if then we had something like this? What if I had 5z to the negative 3, and again the goal is to make all the exponents positive. My question to you is does 5 have a negative exponent?
Yeah. No?
What is the exponent on 5?
1.
It's 1. So it doesn't have to move. If you move it, its exponent's going to become negative. We don't want to do that. So the only thing that would move here is the z to the negative 3. So 5 staying in the numerator. Z to the negative 3 is going to go to the denominator and become z to the positive 3. 5 over z cubed. Okay, so we got one more rule to learn, and then we're going to throw all of them together and do some simplifying. So let's look at our last rule. The quote from one of the students in the class was crap. Crap. Okay. Actually, it was cramp, which might have made her think crap. I don't know. Maybe. Okay, so the last rule is called the power rule. As Tim Taylor would say, more power. This deals with when we would have something raised to a power, and that's raised to a power. Now, Aaliyah claimed earlier that when this is the case, we're going to multiply the exponents. Let's see if she's right. So this isn't part of your notes. We're just thinking. If I had x squared cubed and I thought about what that meant, wouldn't that mean x squared times x squared times x squared? Well, is it or not? Is that what that means or not? Is that what x squared cubed means, class? Yes, it does, which would give me x to the 6th. And what we're trying to do is go from here to there and skip all this garbage. And do you see that we would indeed multiply the exponents? 2 times 3 gives us 6. So Aaliyah is right, and that's why she's right. Okay, so if I have a to the m, all raised to the n, that's equal to a to the m times n. That's the power rule. What I usually say to my students is, if you got the exponent on the outside, multiply the exponents. And do that, David, come on. Do that first. That's always the first thing you do on a problem. The outside exponent. Okay, so if I got p to the 8th and all that's raised to the 3rd, I bet you can see that that's going to be p to the 24th. if you've got something like this, 3y squared to the fourth yes, ma'am.
So the 3 has an exponent of 1, right?
Mm-hmm.
Yeah, because it's not the same.
That's right. And that 4 has to be multiplied by all the exponents on the inside, not just the 2.
Yeah.
So don't forget that the 3 has a 1. So 1 times 4 is going to give me 3 to the fourth. 2 times 4 is going to give me y to the 8th. Do you might know what 3 to the fourth is? 81 is right. Grayson was almost there, but she wasn't quite there. 81 y to the 8th.
Yeah, that's what I'm trying.
Well, a quick way to do that one in your head is if you take, you got to have 4 factors of 3. So if you pair them up 2 and 2, 2 factors of 3 would make a 9.
Mm-hmm.
And 2 more would make another 9, then you can get the 81.
Oh, okay.
So,
That's
okay. All right. Well, ladies and gentlemen, we're going to close with some hairy problems, big long ones. Hairy long problems, that's right. So look, I'm going to say this, and I'm going to hope that you get this. So maybe I'll do something weird while I'm saying it, and it'll help you remember. Probably not, but my students have trouble remembering this. So, okay. I know this is weird. It's weird to me too. But listen, do the outside exponent first. Then do the negative exponents. Then multiply or divide. What are you doing first? Then what? Then what? Okay. Very good. I'm glad that's not on video. Let's just say that. Okay. All right, so let's do this big old problem. 3x squared over y, and that whole thing squared. Oh, we're not done yet. We're barely started. 4x cubed over y to the negative 2, and then that's going to be raised to the negative 1. So the directions here are going to say simplify, and that means we don't want any negative exponents in our answer. Okay, so here we go. What are we doing first? The outside exponent. And how do you handle the outside exponent? You multiply. Very good. So what I would do if I were you on these first few is I'd go through and circle my outside exponents first, because that's what we're going to do first, and then multiply them by all the exponents. Don't forget that the 3 has a 1, the y has a 1, and the 4 has a 1. So here we go. 1 times 2 is going to give me 3 to the second. 2 times 2 is going to give me x to the fourth. 1 times 2 is going to give me y to the second. Times. Let's go over here. 1 times negative 1 is going to give me 4 to the negative 1. 3 times negative 1 is going to give me x to the negative 3. And on the bottom, negative 2 times negative 1 is going to give me y to the second.
Y times 2, right?
No. This is a 2, class. I'll put a line through my z's.
Okay.
That is a 2. It does look like a z. I see why you think that. It's kind of, it's a little harder to write on this Dumaflingy here. Yes. Okay, so the outside exponent was first. Now what did I say to do second?
The inside.
No.
Oh, wait, multiply.
No. No. Well, I was jumping around acting like a
Negative, yeah, I couldn't.
Take care of the negatives. Okay, so listen. Every time we see a negative exponent, we're going to move that factor. We're going to change the level. Okay? So, what I usually do this, I call this the stay-go game. 3 squared gets to stay because its exponent is positive. X to the 4th gets to stay where it's at.
That's you, thank you.
Y squared gets to stay where it's at. But 4 to the negative 1 has to go to the denominator so that it can be 4 to the positive 1, or simply 4. X to the negative 3 has to go to the denominator so it can be x to the positive 3. Y squared is already in the denominator, so it's going to stay. And that gives me a 1 right there. Okay, so we did the outside exponents. We did the negative exponents. And then the last thing I said to do was multiply or divide. Okay, so first let's go through and see if we got anything that'll cancel. This is a cancel problem because it's multiply. Well, the y's are on the same level.
You can cancel some of the,
What can I cancel, class?
some of the X's, like.
Some of the x's. That's right, because I've got x's in the numerator, I've got x's in the denominator. So some of those will cancel.
So would it be 1, like X to the 1
Where at?
on,
In the top or in the bottom? In the top. Good. 3 of these x's down here are going to cancel 3 of these up here. So they're gone in the bottom, and that leaves me with a single x up there. Okay, and I don't see anything else that'll cancel, do you? Okay, then let's finish by multiplying. So look, this 3 squared is going to make a 9. Times x is 9x. Times 1 is still 9x. So in the numerator I got 9x. In the denominator I've got a 4. And how many y's do I have? 4. So how about 9x over 4y to the 4th? So listen, don't try to make one problem out of that. Make 3 little problems out of that. Do the outside first. Then go through and take care of all the negatives. And then go through and multiply or cancel. So maybe one more of those? Let's see one more of those? Yes, Mr. Black, I do. Okay, thank you. All right. Let's make this one actually a little easier than the last one. In my estimation, you may not agree. We'll see. X to the negative 4, y to the 2nd, over x squared, y to the negative 5. So on the last problem, we said to start by circling all the outside exponents. Well, this problem doesn't have any, right? So that's done.
so you just go to the negative?
Yep, let's go to the negatives. So you guys work on the negatives, and I'll pause here for a minute, and we'll see if we agree with each other here in about 30 seconds or so.
So you want to sort the problem?
Yeah, I want you to just get rid of the negatives right now.
Yes, Mayor Leaner.
Well, I didn't know you felt that strongly about my leadership, but thank you, Anthony. Much obliged.
Yes, Mayor Leaner.
Okay, so we don't want to make this more difficult than it is. Let's just move the level on the ones that have a negative exponent. So this x to the negative 4th is going to be x to the positive 4th in the denominator. Y squared is going to stay where it's at. X squared is going to stay where it's at. But y to the negative 5 has to go to the numerator, so it can be y to the positive 5. Okay, now let's finish this problem off. So we'll either multiply or cancel. This time nothing cancels. Okay, nothing's common in the top and the bottom, so nothing cancels. So in the numerator I have y to the 7th, and in the denominator we have x to the 6th. Ding, 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 ding. Okay, this is going to take a while to write this assignment, so just fair warning up front. Page 274, 13 through 18 are good problems. 23 through 26 are good problems. 39 through 42. 67 through 74. 79 and 80. Some of these problems are literally like 5-second problems, by the way. Yes. 79 and 80. 97 through 102.
Where's the hundreds? Oh my.
And I want you to ask me about 136 and 141 next time. So you don't have to have those done when you come in, but somebody needs to ask about them. All right, that'll do.